Hi everybody, welcome to topic number 26, adding, subtracting, and multiplying radical expressions. Just as like terms can be combined by adding or subtracting, you can also combine like radicals in the same manner. Radicals with the same index and the same radicand are like terms. So before we've learned things like 3x plus 2x equals 5x. Now we're saying that as long as things have the same root. So for example, square root of 5, square root of 5, they can be combined in the exact same way. In this case, the x's are just like the square root of 5's. And we're just going to go through and combine the outside number and keep the radical the same. Much like with like terms, we just combine the coefficient and we keep the variable the same. Things that do not have the same radical, for example like this, would not be able to be combined. Also, things that have different, so here I have 3 to the cube root of 5 plus 4 to the square root of 5. Yes, they both have 5 on the inside, but this one is a cube root and this one is a square root. They would not be able to be combined as well. Just the same way like you can't combine x and y as like terms. So let's show you some basic examples. So here they both have a square root of 11. So we can go through and combine their outside numbers. 4 plus 8 will give me 12. We'll leave the square root alone. Same thing here. Both of these have a cube root of 3x, and they would both have to have a 3 in the x. The variable and the number on the inside both have to be the same. So in this case, we're doing 5 minus 7, which is negative 2, and then we're leaving the radical alone. So this would be my final answer. Now again, as you look here, this is a square root. This is a cube root. These do not combine together. So in the same way that if I had, for example, 3x plus 5y, and we said combine it together, we would leave this as our final answer. This is the final answer. It cannot be combined any further. Now on D, we cannot combine these as they are. But one of the things we have to be able to do is check and see, can we simplify the radicals to make them combine? So for example, we learned that from the last video that we can simplify 20 by taking this and doing 2 times 10, with 2 being prime. 10 would become 2 and 5, with both of these being prime. So in this case, I have a pair of 2's, one of them coming to the outside, and I have a 5 left over, so this becomes square root of 5. Plus 2 times me breaking down 45. So 45 is 5 times 9, with 5 being prime. And 9 is 3 times 3, which means I have a pair of 3's. So the 3 would come on the outside and the 5 on the inside. But now if you notice, these are like radicals, so I can combine them. I would first multiply this out, 2 square root of 5 plus 6 square root of 5. And then again, I'm going to combine the outside numbers and leave the radical alone. 2 plus 6 is 8. So the answer here is 8 square root of 5. So we have to check and see, can these radicals simplify? And if they simplify to have like radicals, then we can go ahead and combine them. Let's do a couple more. 63 is 9 times 7. And 9 is a perfect square that becomes 3. 7 is prime, and both of these 3's are prime. So this would become 3 square root of 7. Since this is already square root of 7, we don't need to change this. We'll say it's minus square root of 7. We would subtract the outside numbers, remembering that if there's no number on the outside here, it's the same as really writing a 1 there. So 3 minus 1 is 2 square root of 7. My final answer here would be 2 square root of 7. We're going to do the same thing here. We're going to simplify these radicals as best we can and multiply it by the number on the outside. Now again, these are both square roots, so we're looking for groups of 2. So as I go through 200, I know that 200 can be 2 and 100. 2 is prime, And I know that 100 is a perfect square. 100 becomes 10 times 10. And even though these aren't prime, I could stop here because I already know I have a pair of 10s. Those 10s are going to go on the outside with the 2 going back on the inside. And I'll take the negative 3 that was already on the outside and put it in front to multiply it by. So again, even though this isn't prime, since these are the same numbers, I could circle them and treat them like as if they are prime. 8 is 2 and 4, with 2 being prime, and 4 becomes 2 and 2. So I've got a pair of 2's, which will come outside with a 2 on the inside, and I still had a negative 5 here that we'll multiply with. And then finally, when I look at 98, 98 is 2 and 49, and 49 becomes 7 and 7. So this becomes, the 98 becomes 7 square root of 2, but I still have a 9 on the outside that I can multiply it by. So I'm going to get rid of all these multiplications. I'm going to do negative 3 times 10, negative 5 times 2, and I'll do 9 times 7. Negative 3 times 10 is negative 30 to the square root of 2. Negative 5 times 2 is negative 10 to the square root of 2. And 9 times 7 is 63 to the square root of 2. But notice they all have square root of 2 as their radicals, so they're all going to be able to combine. Negative 30 minus 10 is negative 40. I can go through and add that to 63, and I would get positive 23 square root of 2 as my final answer. Up here, we're going to take each one apart separately. With the 300x cubed, we'll start with the 300, and then we'll work on the x cubed. 300 is 3 times 100, with 3 being prime, and 100 is 10 times 10. So I know that this will be 10 square root of 3. And for the x cubed, 3 divided by 2 is 1 remainder of 1. So I will have x square root of x here. So this guy can be rewritten as 10x, and on the inside of the square root, I have a 3 and an x. For the square root of 12x, we'll do the square root of 12 and the square root of x. 12 becomes 4 times 3, with 4 becoming 2 times 2. So this is really 2 square root of 3. And because there's nothing here that will simplify, the x stays on the inside. So the square root of 12x becomes 2 to the square root of 3x. We also have this x up here, so we'll go minus x 2 to the square root of 3x. Now I'm going to rewrite this part a little bit nicer. 10x to the square root of 3x minus, we'll flip it around, 2x to the square root of 3x. Again, both of these are square root of 3x, and I can combine this because they're both 10x and 2x, those are like terms. So 10x minus 2x, I have 8x to the square root of 3x. I have to have exact like terms to be able to go through and combine things. Let's show you a couple more examples. Here we've got a cube root. So I need the cube root of x cubed and the cube root of y to the 13th. So this is 3 divided by 3, which is 1 remainder of 0, which means I just have an x that comes on the outside. And here this is 13 divided by 3. 3 goes into 13 4 times with a remainder of 1. So this is y to the 4th with a y back on the inside. Including the 7 that I already had outside, I have a 7, an x, a y to the 4th, and then a cube root of y here. For the 5xy, we'll just look at the cube root of 8 and the cube root of y10. So the cube root of 8 becomes 4 and 2. 4 becomes 2 and 2. So this makes sense because we've seen this before. The cube root of 8 is simply 2. And the cube root of y to the 10th 10 divided by 3 is 3 with a remainder of 1. So this is y cubed with a remainder of y inside the cube root. Okay. So I already had a 5xy on the outside, and I have 3 more y's going on the outside. So I have a 5x, and then this y and y cubed we'll both have on the outside, and on the inside we'd only have this y remaining. Now this y and y cubed, as I move down here, will become y to the 4th. Right? So I'm going to take this y and y cubed, and I'm going to make that y to the 4th. And if you notice here, all of my variables are the same. I have x, y to the 4th with a cube root of y. So all I need to do is just add the 7 and the 5 together to get my final answer. So my final answer here should be 12 xy to the 4th cube root of y. Everything on the variables needs to be exactly the same, and everything inside the radicals has to be exactly the same as well. For fractions, we have like radicals, so that's good. But with fractions, we need common denominators. So I need a number that goes into both 5 and 3. And we know that's going to be 15. 3 goes into 15 5 times, so I'm going to multiply the top by 2. 5 times 2 is 10, square root of 2. 5 goes into 15 3 times, so I'm going to multiply this one by 3. 3 times 3 is 9, square root of 2. So just like with fractions, we leave the denominator alone, and then we're going to combine these, leaving the radicals alone, and really just combining the outside numbers. 10 and 9 make 19, 19 square root of 2. Double check and see, can your fraction reduce? 19 over 15 in this case cannot reduce, so this would be the final answer. We'll do the same thing here. I'm going to take apart the square root for this one. So for this first part, I'm going to leave this alone. But here I'm really doing the square root of 11x squared over the square root of 100. So again, leaving the first one alone, and I'm doing that because there's no number that can go into 11. I already know that's prime. Here, there's no number that can go into 11, but I do know that the square root of x squared is x. So when I do this, the x will come to the outside, but the square root of 11 stays on the inside, and the square root of 100 is 10. So really, I have this here, and I have x squared of 11 on both. So these are like radicals. If we need to here, we'll put a 1 here to remember. There's a 1 in front of it. But I can't add these fractions until they are common denominators. A number that goes into both 5 and 10, in this case, it is 10. Which means I need to take this whole top part and multiply it by 2, because 5 times 2 is 10. So this really becomes 4x to the square root of 11. This was already 10, so we will keep this one the same. The 10 stays on the bottom. I have 4x plus 1x, which is 5x, square root of 11. But this time 5 over 10 can reduce. 5 over 10 becomes 1/2. So I have x square root of 11 over 2 as my final answer. So again, you can combine radicals as long as the radicals are the same, and if they're fractions, those fractions still have to have common denominators. We have to follow those rules as we do it. Just like we can add and subtract with radicals, we're going to do pretty much the same thing as we multiply. We're going to just follow the rules of multiplication with it. When we multiply things, you can multiply things that are inside the radicals together. You cannot multiply things that are outside the radicals together. So for example, if I had 3 square root of 5 times 4 square root of 2, I could do the 3 and the 4 and make that 12, and I could do the 5 and the 2 and make that 10. Inside goes with inside, and outside goes with outside. And again, we have to check and see if we can simplify it as we do it. So in this case, this is a distributive property. 6 times 5 is 30. And 6 times 7 is 42. Now for 30, it's 6 and 5. 5 is prime, 6 becomes 2 and 3, so no pairs there. 7 is prime, and again, this is 2 and 3. So this is as far as we can go with this one. For B, we don't need to look to simplify. 7 and 11 are all prime numbers, so we'll do it pretty much the exact same way. 7 times 11 is 77. 7 times 7 is 49. Now here, we can simplify this because the square root of 49 is a pair. Square root of 49 would become 7. These would not combine. So you would either leave your answer like this, you could also write it this way and be okay. Remember, when you square something, you multiply it by itself. So this is really just saying square root of 7 minus square root of 2 times square root of 7 minus square root of 2. And we're going to FOIL this out like we've done before. We're going to multiply everything in the first polynomial by everything in the second polynomial. Okay. Square root of 7 times square root of 7 is square root of 49. Square root of 7 times negative square root of 2 is negative square root of 14. Negative square root of 2 times negative 7 is negative square root of 14. And negative times negative is positive. 2 times 2 is 4. So a couple things we could do here. First, we know what the square root of 49 is. The square root of 49 is 7. We also know what the square root of 4 is. The square root of 4 is 2. And inside in the middle, these are like radicals. So we can combine those together. Remember, what's there's no number on the outside. We pretend like these are 1s here. So I'm doing negative 1 minus 1. So that gives me negative 2 square root of 14. This negative 2 square root of 14 won't combine with 2 and 7, but 7 plus 2 can combine to make 9. So this would be 9 minus 2 square root of 14. Again, this doesn't have a radical and this does, so they will not combine, and this is as far as we can go. 14 we know won't break down because 14 is simply 7 times 2. So this here would be our final answer. Again, we're going to distribute here and then look to see if we can simplify after. So everything's inside the radical, so they can multiply. 2x times 2 is 4x, and then 2x times x is 2x squared. Well, when I look at this, the square root of 4 is 2, and the square root of x doesn't change. So this can become 2 square root of x minus, and when I do this, I have the square root of 2 and the square root of x squared. The square root of 2 can't simplify, so it's still square root of 2, but square root of x squared can simplify. Because remember, that is just 1x. 2 divided by 2 is 1. So this will become x with a square root of 2. These do not have the same radical. They will not combine together. This would be my final answer here. Here's another process of FOILing. 6 times 3 is 18. Y times y is y squared. Then we'll do 6 square root of y times negative 1, which means it's negative 6 square root of y, because anything times 1 stays the same. This would be z times 3 square root of y, so it's really 3 times z. So 3z, still with a square root of y, and z times negative 1 is negative z. Now, we cannot combine these middle terms here. Even though they both have square root of y, this has a z on it, and this one doesn't. So these are not combinable. The only thing we can do to this is simplify this, because we do know that the square root of y squared simply becomes y. So this becomes 18y minus 6 square root of y plus 3z square root of y minus z. Nothing else has a y just by itself. Again, these two square roots won't combine because of the z here, and nothing just has a z by itself. So this is as far as this problem can go. In our last one, we're doing cube roots. So the cube root of x times the cube root of x is the cube root of x squared. Cube root of x times 2 is 2 cube root of x. 5 times the cube root of x is 5 cube root of x. And then 5 times 2 is 10. So this won't simplify. 2 divided by 3, there's not enough that goes into it, so that stays the same. But these are like radicals. They both have cube root of 3. So they will combine. 2 plus 5 gives me 7 cube root of x plus 10. So again, this won't combine with this because this is x squared and this is x. And this won't combine with 10 because it's just 10 by itself. So this is our final answer here. Again, another FOIL process as we go through and do it. Here again, we'll do the outside numbers times each other in the inside numbers. So 5 times 6 is 30. Square root of 3 times square root of 3 is square root of 9. 5 times negative 4 is negative 20. And it still has a square root of 3 with it. 9 times 6 is 54. And it still has a square root of 3 with it. And then 9 times negative 4 is negative 36. So a couple things we could do. We know that the square root of 9 is going to become 3. So it says 30 times square root of 9. So it's now 30 times 3. And let's rewrite the rest of the problem down here. And 30 times 3 is simply 90. So I'm going to change that value there to 90. Right? So all we did was this multiplication. And now we have like terms to combine. 90 minus 36 are both whole numbers. So 90 minus 36 is 54. And then we can also combine these in the middle because they have like radicals. They both have square roots of 3. Negative 20 plus 54 is positive 34 square root of 3. These will not combine. This one has a square root and this one doesn't. So we will leave this as our final answer. Again, anything that's squared multiplies by itself. And again, this is a good time to remind when I do this times this, it's the same thing. And if you think about it, every time I've multiplied something that's the same, what's happened? Square root of 3 times square root of 3 simply becomes square root of 9, which just becomes 3. So if you multiply a radical by itself, the radical goes away. So I can use that trick here. This times this is simply going to be x minus 4. The radical is going to go away here. This times this is 3 times x minus 4. And then we have the same thing here on the inside. And then we have 3 times 3, which is 9. So a couple things we can combine. We can combine the negative 4 and the 9. That will become 5. Nothing combines with this x. It won't combine with the ones in the radical. So I have x plus 5. And then these guys are like radicals. They both have x minus 4 on the inside. So we will combine the outside numbers. 3 and 3 make 6. Now again, don't combine this 5 and the 6 because the 6 is really attached to this radical. And we can't combine the x's because again, this is all attached. So this is as far as we can go with this problem. So as you're doing combining like radicals, you have to think of it like like terms. It has to be exactly the same to combine it, and we leave the radical part and the exponent parts alone, and we simply combine the coefficients together.